I think the talk was originally something about there is no green field, so from Aldi Süd, but we actually had the greenfield position as a startup, and we could build our own observability tool based on OpenTelemetry, and I will talk a little bit about that. Not so much about the tool, but more about OpenTelemetry and how to do observability. A little bit about me. I'm co-founder and CEO of Dash0, and before that I already had the observability APM company called Instana. We were especially built for Kubernetes and APM for microservice at the time. We sold to IBM in 2020, and before that I co-founded a consulting business here in Germany called Codecentric, also has an office here in Hamburg. And in between selling IBM and founding Dash0, you always have a lockdown period. So for like 2 years I couldn't do anything in software. I did a lot of angel investments, so more than 70 angel investment in mostly SaaS startups. I saw the talk before. I'm actually an investor in Edgeless, which is something in that area of secure Kubernetes. So if you have a startup and you're looking for an angel, open for business. Yeah, but today it's about observability, and I start with this slide because first of all, the slide shows that I'm pretty old because I started in that area in '99 when I finished studying, and I was one of the. I joined IBM, and I was one of the first Java developers here in Germany building. That was like the big bubble thing, and I was building a big platform for TUI that sold the first online stuff like flights and hotels, and that was not working. I think we had WebSphere, who remembers that, and every time there was the fourth user coming, it crashed. And so I needed a tool, and I actually found Wiley. At that time, it was the first APM solution that actually used instrumentation, and we'll come to tracing, used instrumentation to look into your code as a developer in production, and you could see actually how the application is running, and you could optimize it. And that was a category called APM. And then over time, there were other categories. One is Splunk, you probably know. They actually did the work that you don't have to log into all the shells and look at the logs with tail or something, and you could just send them into a centralized database and then query, search, slice and dice the logs. That was log monitoring. And then there were classical monitoring tools like Nagios. And you can see over time, in 2005, 2006, there were new vendors like Dynatrace out of Linz in Austria, and then AppDynamics in the US, and New Relic, founded by the same guy who founded Wiley, Lucerne. And then came Datadog, initially only infrastructure cloud monitoring tool. And what happened then is that those categories emerged together. So that was kind of the first thing. So today, most of the platforms have APM, so tracing, looking into your application. They have logs, and they have monitoring. They have also multiple other categories that I'm not mentioning, like real user monitoring, static monitoring, network monitoring. But basically, everything is going into one platform. And then around 2015, 16, some new vendors, one of them was us, Instana, and the other was Lightstep. Maybe you know Ben Siegelman, the initial Google author of the DEPA paper for distributed tracing, which then became Open Tracing, and then finally became OpenTelemetry. Founded that. We got acquired by IBM. Lightstep got acquired by ServiceNow, so you can think of both tools being dead. Because in those companies, they go to die, right? There's no innovation anymore. And so then there was Honeycomb, the third one, and they are still alive. They are still around, really good tool, check them out. They were one of the first also forming this idea of observability as a new term. And I'm just giving you the update because at the moment there's a lot of marketing, I would call it bullshit, around observability, right? Because every vendor now says they are observability, and I think it doesn't matter that they do, but you will hear a lot about 3 pillars. We talk about that, logs, metrics, and traces. But essentially it is a combination of mixing all categories together, right? So you have all data in one single view with high cardinality, and we come to that too. And and then making you, giving you a tool that you are able to slice and dice that data basically in production at runtime. And that allows you to watch for unknown unknowns, right? And that's basically the difference. In monitoring, in the old world, you basically monitored what you knew could fail, right? You had dashboards, metrics, and you looked at them. But now in Kubernetes and in these container environments, there are so many moving parts that you probably don't know what to monitor. And then you need a tool that helps you basically slice into the unknown unknowns, and we will come to that. And last but not least, 5 years ago, OpenTelemetry was born. Out of different standards. They merged together. It's a CNCF project, same as Kubernetes or Prometheus. And they standardized a few things, which I will talk about. And that's, I think, a really nice change for the end user, for you guys. It was not so nice for us as a vendor, because it took away a lot of our IP, and we were actually pretty scared at the time. But today, I think it's really an established standard, and it does a really good job. And so what is OpenTelemetry? I will probably first start what it is not. It's not a tool, right? It's not a tool that you can download and do observability. That's not what it is. It's also not a data store or a front end, so it doesn't store your data. It does not visualize your data. It actually standardizes the way the data is collected, right? And actually generated out of your application or out of your infrastructure. And that's, so before OpenTelemetry, every vendor built their own agent technology, right? We had that at Instana too, so we had our own proprietary agent. You installed the agent on your application or as a daemon set in Kubernetes, and then we instrumented the application. And instrumentation means, in Node.js or Java, you connect to the running process and you inject code to, for example, get the logs, the traces, and the metrics out of that process, right? So it's pretty going deep into the application. It's also pretty, can be dangerous, right? If you do a mistake, it crashes your application. Shouldn't happen. Sometimes happens. And so OpenTelemetry is open source. And you have an API and SDKs. So as a developer, you can just take the SDK and you can inject traces, logs, metrics yourself into your code based on a standard, right? So every vendor who is OpenTelemetry compliant, which I would say almost every vendor today is. So if you look at the Grafana, Elastic, they can use it, Datadog, the ones you saw on the slide, right, Dynatrace, they can all take OpenTelemetry. So you can basically instrument your code, and you can be sure that most of the tools out there, open source or not, can take your data. And one of the benefits is that that also means that vendors can put it into their code, right? Think about platforms like Vercel or Cloudflare, so serverless, or AWS in the serverless way. There you can't install an agent, right? It's not possible. You don't have access to the actual servers and hardware. And so now what happens is that those vendors, they put OpenTelemetry into their stack, like Vercel does, and then you can get the data of your application out of that platform in OpenTelemetry standard, right? The protocol actually is called OTLP, right? So you get this OTLP stream of data, and you can send it to a platform, and you can mix it with your own data, which is pretty cool. So you have the API, the SDK, and some vendors also gave to the open source community their auto-instrumentation. So what I told you, what most vendors had is that you don't have to do it manually. You can just connect to Java, Node.js, .NET, whatever, and then they will do the job, the agent, automatically. And there is, I think, 6, 7 auto-instrumentation agents, open source for free. You can just download them on the OpenTelemetry website, and that auto-instruments your code. So either because you don't have access or you don't want to do the work of manual instrumentation, you can do this automatically. And then in the middle, you have the OTel collector. This is kind of the agent, right? We will come in the Kubernetes scenario, how to deploy it as a daemon set. And so the API, the SDK, or the auto-instrumentation will send the data locally to that collector. And that collector can then send the data to a backend or wherever you want, right? So this is how it works. And the collector is a standard component you can download. The agents are standard components. And there is a specification of the API, SDK, etc. There's also a third component, which we will talk later a little bit more, which is called the semantic convention. And this is a standardization of the tagging system that is used. So normally, if you have data, you tag them, right? So let's think about, I don't know, Kubernetes pod name, right? And the problem before OpenTelemetry was that every vendor named them in their way, right? Could be Kubernetes.pod.name, the next says K8s.pod.name, the next says K8s_name, right? So there are many versions, and for a tool, it was very hard to bring that together. And by standardizing that, you have a lot of cool options, which I will deep dive later. What is the data? So OpenTelemetry actually calls that signals. There are 3 actually standardized final signals in OpenTelemetry. It's metrics, I will come to that later, logs, and traces. Yeah? Actually, it spans. Who is familiar with the concept of distributed traces? A trace is a collection of spans, and a spans is an individual call, like an HTTP call, or a gRCP call, or a database call, or just a call in your code. And then if you put them together, they are actually connected. Every span can have a parent span, and that way you get a tree, and that whole tree is called a trace, right? That's actually what it is. And so you can see the flow through your Kubernetes services, etc. And that's standardized, and there are 2 more specifications that are not final yet, but almost final. It's profiling. The difference between profiling and tracing is that the profile is focused on one single process, and it basically looks at CPU usage, blockings, and it's good for analyzing a single process and for optimizing, for example, CPU usage. And the next one is RUM, real user monitoring. This is how a user interacts from a browser or a mobile phone with your application. And those 2 signals, RUM and profiling, they are not final yet, but they will come, I would say, this year. And then you have 5 signals standardized in OpenTelemetry, which I think is pretty cool. And then let's talk about metrics, and especially if you hear it, the word cardinality. I mean, metric is pretty clear, right? It's a time series. It can be anything from CPU time of a node, right? And I have shown here a few, for example, and that's already the standard naming convention for Kubernetes. So you can see Kubernetes node, and then there's CPU time, and there's a certain time, like a sum or a gauge, and you actually have the time series, and you can do things with it. The interesting part is you see here cardinality. What does cardinality mean? And think about, we have a metric called Kubernetes node CPU utilization, and now we can put tags on them. And the tag could be the node name, right? Because we want to see the CPU utilization by node. And each of those tags actually creates a new time series. So think about it, if I have node name and I have 20 nodes, I need 20 time series to have the metric per node. And you can add unlimited number of tags, so unlimited number of cardinality, which you can see. And most vendors, us too, they will charge you for the number of time series and your cardinality, because every single time series costs money, because you have to store it, you have to process it. And so what can happen is actually a cardinality explosion. Think about, you have a metric number of users, and you put in, and I've seen it, you put in a tag IP address. Now, you get the IP address of the user coming in, which is individual for every user. If you have 1 million users, you will have 1 million time series, right? Because you have a time series per IP address per user. So you have 1 million, and this can cost you easily $10,000 with Datadog, right? So just because you did the wrong tag, it will explode, right? And it costs a lot of money. So be careful with cardinality. Think about it. Think which tags you apply to your data, because it can actually explode. We therefore show you the cardinality, and you can actually look at each individual metric and see if it's correct or if it's exploding or not. And you can also set alerts on it. So if it explodes, that you get an alert and you don't get shocked at the end of the month. Why do I pay? I actually saw a tweet 2 days ago that someone did it wrong and paid $300,000 in 1 month, right? So it can happen. And then there's also something that is not standardized in OpenTelemetry, and there is actually a discussion if it should. There are pros and cons. I actually would be pro standardizing the query language, because now you have data, metrics, logs, and traces, and you want to query it, right? You want to get it out of the database. And I'm just showing you, I would say, 4 standard ways of doing it. One is PromQL. This is from Prometheus, right? So you know Prometheus had a query language, and it's called PromQL, and it's I would say widely used, right? It's also used in Grafana, for example, for metrics. So people know it, and it's kind of a standard, but it's not standardized, right? It's just an open source PromQL widely used. On the right side, I just did a screenshot, is Kusto. Kusto is from Microsoft, and a lot of vendors use it. This is like a pipe style of using things. Maybe you know it from Splunk or Elastic. So a lot of log vendors used it. I think it's actually somehow easier to understand than PromQL because it's more structured. You're reducing it in pipes, and it's widely used, so that could be one. SQL is also highly discussed because SQL is actually a language that a lot of people know, and you could just query metrics using SQL. Sometimes it's a little bit chatty, but last but not least, you could also do it just by creating a visual editor, right? And not using a language at all. That works for easy use cases. For a lot of use cases, it doesn't work, right? So we have chosen PromQL, and the reason for that is that we think it's pretty much used widely and standardized, and you can just connect a Grafana dashboard, or you can do some of the alerts, which I will show you, that are out of the box. But overall, there's no standardization, and you always have to see what's your preference, right, of querying. Some people like Kusto more, some SQL, and you have all of that out there. Yeah, and then you have dashboards, right? So normally you put metrics somewhere, and you can put them on dashboards. And also there are a few open source, which are pretty popular, Grafana being probably the biggest. And you can just download it and use it. Then there is Kibana, which actually was before Grafana. Grafana was kind of a copy or a fork of Kibana, as I remember. And then it started from there. Kibana is from Elastic, so you have Kibana, Grafana. And there is a new standard which actually became a CNCF project. It's called Perses. And we use Perses, right? Perses now is the first time that actually dashboards get standardized. And the advantage is, if it really becomes popular, and we are the only vendor actually at the moment that supports Perses, so it's not really a benefit right now. But in the future, if most of the vendors would use Perses as the standard, maybe even Grafana, then you could interchangingly, so if you have one tool and you build 200 dashboards, you can just export them and import them in another tool, and it would work out of the box because it's a standardized format. That would be highly beneficial because it's a big problem for a lot of people who have invested a lot of time to switch from a tool because you can't take the dashboards with you, right? So Perses could be a very interesting thing. Check it out. I think it's a very interesting project, actually built by Amadeus, the flight booking solution. I think it's from Lufthansa and the big company that does most of the flight search and booking stuff in the background. And then you create checks and alerts, right? Also on the metrics. I mean, you know how it works, right? You say, hey, there's a CPU. If it gets higher than 90%, it's warning. If it's 100%, it's red. And then you can send the alerts to a channel like Slack or PagerDuty or whatever, right? That's what you do with metrics. So metrics is part of OpenTelemetry. And yeah, I just wanted to show you this. Because if you use PromQL, I can just, if you haven't checked it out, there's a GitHub project called Awesome Prometheus Alerts. We have actually integrated into the UI, and it's free, and there are more than 500 predefined alerts based on PromQL and Prometheus alerts, and you can just download it, right? And I've opened it for Kubernetes. You can see Kubernetes API client errors or whatever, and if you take it, like here, container out-of-memory killer, there is already the PromQL for it, there's already the data source, the metric names, and you can just take it, download it from GitHub or just use it, and you don't have to invent all the alerts yourself. And I found it quite interesting. It's the power of the community and open source that you have people who share their ideas how to check and monitor MySQL and whatever, right? You have 60, 70 different databases and checks here, and you can just use it. So highly recommended to check out the repository. Yeah, the next thing is logs. I think there's not too much to say. I will come to context later, but it's basically structured, unstructured text with tags that are that you can query, filter, slice and dice, and I think it's a pretty common thing that especially developers use to debug their applications. And last but not least, it's traces or spans. That's the third pillar. And I think especially in microservice environment, this is super, super interesting because it actually gives you dependencies. So normally all the logs and all the metrics, they have no dependencies, right? They are looking at one single slice. So if you have a service A, service B running into pods and A calls B, you would never really know this from metrics and logs. I mean, you can log it, something like A calls B, but that's just text, right? But with spans and traces, you actually understand that A calls B and you get a real dependency, and you can use this for troubleshooting, visualization, etc. Right? Oh, sorry. And I'm just saying this is part of the context, but telemetry data without context is just data, right? And I will explain what that means. I will explain also how OpenTelemetry, I think this is the biggest part of OpenTelemetry, has solved that problem, right? It's like the Tower of Babel, right? If we talk one language, there's basically nothing impossible, right? But if we take the language, nobody will understand each other. And that was the pre-OpenTelemetry thing, right? No observability vendor could talk to the other observability vendor. Everything was proprietary. You could not merge the stuff together. And this has changed, right? This is a semantic convention. You can check them out, right? It's GitHub repositories, pretty well documented, and there are actually 4 of them. Trace semantic conventions. That's the conventions how to tag traces. There's a metric semantic convention and a log semantic convention, and actually a resource semantic convention. And all 4 of them basically form a way to bring things together. And I give you just an example here, of course, a Kubernetes example. So attributes are key value pairs, and they are specified. And as an example, here is actually how a pod UID is specified in OpenTelemetry. It's k8s.pod.uid, and then it's also a specification how the string should look like, or the value could be an integer, could be a string, could be something else. And now you can basically add that Kubernetes pod UID to every of your telemetry data, and that would actually identify that that metric, that log, that span came from that pod. And why is this interesting? So let's look at resources. It is interesting because now we can create resources as a context. And a resource is a little bit of a weird, it's a little bit hard to understand because it's actually only key value pairs, right? And now you can see on the left side there's kind of a structure, right? You can see services, resources, Kubernetes, namespaces, nodes, pods. This will look familiar, and this is all derived from the tags. So you can create actually structure, and every of these line items or every of the nodes in the tree is a resource, right? Because it's actually a view on your data depending on the tag. So if I see there is a Kubernetes pod tag, I know, oh, this is a pod, right? If there is a cluster tag, you know there's a cluster. And from these tags, you can think about if you take all the tags of all the telemetry data, you actually have an inventory, and you can actually create structure, and not only structure from a Kubernetes view, you can do the same from a cloud for AWS or Azure or Google Cloud. You can do the same for logical things like service things, applications. So the resource concept is super powerful because it adds structure to your data. And now you can use that structure to actually create things like dependency maps, right? Or you can create these so-called red metrics, requests, errors, and duration per resource. You can, for a service, you could show the number of instances because you know that that's also a resource. You can extract things like runtime environment, platform, cloud, the whole Kubernetes structure, add that to a resource because it's all based on tags, right? And another thing is that you can also add that context to each individual telemetry data. So if I look at the log again, this is the same screenshot, I just marked it now, you can see on the top right, I see exactly that log was created in that method, in that span. Now, I have a connection. Because they use the same language, I can now say, oh, this log was actually created in this part of the code, and you can now exactly see where it is. And I can also say, it was actually created on this pod and in this environment in .NET. So this log is now not only text, it gets context, right? And you can use that context for troubleshooting, for filtering. I mean, in reality, you have hundreds of millions of logs entries, and by using that context, you can just say, show me all the stuff that was created in this error scenario, or in this method, or on this pod. And this is really a magical tool that OpenTelemetry has created to give you the power to create context around telemetry data. And the same is true for a resource. If I go back, if I look at a resource, I can, for example, say, show me all the spans and logs of that service, right? So now I have all that in the context. And again, a resource could be everything. Show me all the logs of the cluster, show me all of the pod, of that container, of a service, doesn't matter, right? Of an operation. So you can use anything that is a resource in OpenTelemetry to nail it down and get the context and get a view on the spans and logs, right? So you can see I'm a big fan of OpenTelemetry. And so now the question, how do I get OpenTelemetry data in Kubernetes, right? We were talking of Kubernetes, and it's actually pretty easy, right? So you can set up a collector and as a daemon set and as a deployment. And then there are so-called attribute processors. So basically now you have to automatically add the tags, right, for a pod. And the collector will do that automatically for you. So you can essentially just deploy it. You have to do some configuration. And you will automatically tag everything that runs in the container and the cluster, automatically get all the tags. You don't have to do that manually. All the infrastructure stuff. You will get the metrics. You will get the logs. And you can use the zero code instrumentation. So even if you don't have instrumented your code, you can use the agents for 6, 7 languages and automatically get the spans and traces. So basically, no work you have to do. It's only configuration and deployment. There's actually a Helm chart how to do it. Hopefully you know what it means. I'm not that technical anymore, but I heard it's easy. To just copy-paste it, and you use the Helm chart. And this is all standard, right? This is not something you do only with our tool. You can do this with, you can use Jaeger, you can use Grafana, whatever. This is the standard. You can see it's out of GitHub. It's a standard collector. You take it, you configure it, and your whole Kubernetes cluster and all the services are auto-instrumented with OpenTelemetry, and you can send the data to any tool that you like, and switch tools. You can experiment, and this is the power really of OpenTelemetry, that there is no dependency anymore to the vendor with regards to the data, and you don't need proprietary agents, and you can actually see what's doing. It's highly tested, used by thousands of users, not so much problems, crashing things, etc. So I can just recommend you doing it. We support this with open source. We actually created an operator. So if you don't want to do this, now you have a Kubernetes operator that does all the work for you. So you just say, you just install the operator, run it, it's done, right? It's open source. It's Apache 2 license, so you can freely use it. You can. It just released a few days ago, and we also have something called OTel bin. I'll show you here. It's free, also open source, and there's a website you can use, and it's a visual configuration tool for your OpenTelemetry collector configuration. The collector configuration is a little bit tricky sometimes, and so we built a visual tool that visualizes the configuration, can be the pipelines, and it also has like an IDE, so you have auto-completion, you can't do things that doesn't work, it has, it looks at errors and stuff like that. So it's free, you can use it. Some of the vendors have put in their own collector, so you can validate against different collectors of different vendors, like AWS or Splunk, and yeah. Just check it out. I think it's much easier than doing it manually. Yeah, and we are here at Boost D8. I see I'm 10 seconds over. But yesterday we released our beta, so we don't have a final tool. You can't buy it yet, but you can use it for free and check it out. If you have OpenTelemetry data, just send it there. Look if you like it. The beta program started yesterday. Thank you.
Cool, thank you, Mirko. We do have a few questions, and 10 seconds over is OK. So the first one is, how do you inhibit vendor lock-in when choosing an observability solution? I think OpenTelemetry kind of does that, right?
Absolutely, yeah. So OpenTelemetry is one way, right? So at least you don't get the dependency on the agents, and especially the agents are not that of a problem, right? Because you could switch agents, but especially if you instrument things yourself. So if you use a vendor-specific SDK or API, then you are really locked in, right? Because then you have to remove it. So if you do something like that, always use a standard like OpenTelemetry. And then also on other things, like I think everything that's standard-based, right? Prometheus alerts, PremQL or Custo or Perses, Grafana. I think everything that kind of is a standard or has a community gives you less login than and possibilities than going to a proprietary vendor.
Yeah, and you can use OpenTelemetry with any vendor. So
absolutely, said, yes, yeah.
Most, if not all.
I think most vendor, New Relic, Datadog, you name it, they all support OpenTelemetry, yes.
OK, next one is, can an app instrumented with OpenTelemetry be integrated, scraped with Prometheus?
Yes, not out of the box, because the semantic convention, so the convention between Prometheus uses underscores and has a little bit different semantics. As far as I know, this should be fixed with Prometheus 3.0. One of the goals of 3.0, the next version, is to bring it together. Today, you have to create, there are open source adapters. So yes, but it's not the same language, so you need kind of an interpreter in between, which is available open source to move between Prometheus and OpenTelemetry.
So it's not a simple plug and play.
It's not plug and play, yeah.
Next one, process of switching from Prometheus scraper to OpenTelemetry, should they coexist? Should it be replaced?
I mean, it's, as I just said, you can use both, right? So I'm a big fan of OpenTelemetry because it's standardized, but you can use both. I think there is no, so they can coexist. You don't have to replace them. It really depends on your situation, right? If you are bought into the Prometheus stack, use it, right? Yeah.
Next one, storing logs with OpenTelemetry, is Elastic an option or not?
Yeah, it's an option. So Elastic supports OpenTelemetry, yes.
Yeah. Cool, quick, nice and easy. I've got one myself. How do you reduce the amount of noise when collecting logs, metrics, traces? I usually find my logging exploding, and then I need to either shut down, disable the alerts, which is probably not the right thing to do, or removing things. Is there a kind of starting point on how to understand what to start collecting? I mean,
if you look at logs, I think there are different ways of doing it. There is log grouping, intelligent log grouping. So basically looking, oftentimes if you have a problem, right? We had a customer that's got a connection reset by peer. You maybe know it from something happens and then the Apache or Nginx logs it millions of times. And because it's all the same, you can group it together, right? That's one part of noise reduction, so grouping. But essentially, it's not that easy, right? Because also throwing things away is always a problem because sometimes you need it, right? And that's the issue. So I don't think there is a real good solution for it. I think the good solution are dropping it at some time, right? Retention, grouping it, and doing sampling, right? If you want. That's the 3 good options.
OK, cool. So just on time. Thank you again, Mirko. Please, round of applause for Mirko.
Thank you.